Hello everyone, welcome back to the channel. I am Yasaleduri Manna and today we are going to learn about graph representations and our main focus will be on something called adjacency list. I know the word graph might be sound a bit confusing or even scary at first, especially if this is your first time learning it. But don't worry at all. By the end of this video, you will realize that graphs are actually very logical and quite interesting. Graphs are a very important topic in data structures and algorithms. They are used in many real-world applications such as social networks, maps, web links, and recommendation systems like YouTube and Netflix. Before we start solving graph problems or learning graph algorithms, we must first understand how graphs are stored inside the computer's memory. And that is exactly what today's lesson is about. By the end of this video, you will clearly understand what an adjacency list is, how nodes and edges are represented, simple example of adjacency list, how adjacency list compares with adjacency matrix, and where adjacency lists are used in real life. So let's get started. Before we talk about adjacency list, let's find out what a graph actually is. A graph consists of vertices, also called nodes, and edges, which are the connections. Vertices represent entities such as people, cities, or web pages. Edges represent the relationships or connections between two vertices. For an example, in social network, people are vertices and friendship are the edges. In a map, cities are vertices and the roads are the edges. Graphs can be very different types. They can be directed or undirected, and they also can be weighted or unweighted. Keep these ideas in mind because they will help you understand adjacency list much more easily. Okay, now you might be thinking, now I know what graph is, but why do we even need graph representation? That's a very good question. Graphs are abstract concepts. They exist in our minds, but computers cannot understand abstract ideas. Computers only understand data structures. So we must represent a graph in a way that a computer can store and process. The way we represent a graph decides how much memory is used, how fast operations are performed, how efficient graph traversal will be. There are two main ways to represent graph: adjacency matrix and adjacency list. In this video, we are focusing completely on the adjacency list. Now let's properly define what an adjacency list is. An adjacency list is a way of representing a graph where each vertex stores a list of all the vertices connected to it. In very simple words, every node keeps a list of its neighbors. Instead of storing all possible edges between vertices, we only store the edges that actually exist. This is what makes adjacency list memory efficient, especially when the graph does not have many edges. If you understand this idea clearly, adjacency list will never confuse you. Now let's see how nodes and edges are represented using adjacency list. Usually, we use an array or a list. The size of this array is equal to the number of vertices in the graph. Each index of the array represented a vertex, and each index we store a list of neighbors. If a vertex has many connections, its list will be long. If a vertex has no connections, its list will be empty. For undirected graphs, remember this important rule. Every edge is stored twice. So if node A is connected to node B, A's list contains B, B's list contains A. For directed graphs, only outgoing edges are stored. So the direction of the edge really matters here. Let's understand this using a simple example. Consider a graph with 4 vertices A, B, C, and D. The edges are A is connected to B, A is connected to C, B is connected to D. Now let's write the adjacency list. A contains B and C, B contains A and D, C contains A, D contains B. Take a moment to look at this carefully. Each vertex stores only the vertices it is directly connected to. This is exactly how an adjacency list works. Now let's talk about weighted graphs. In some graphs, edges have weights. For example, we can get distance, cost and time. In adjacency list, we store both the neighbor and the weight. The example I have given for you, this means node 0 is connected to node 1 with weight 5. Node 0 is connected to the node 2 with the weight 10. See, that is simple and flexible. Now let's compare adjacency list with adjacency matrix. As you can clearly see, I have put the differences between these two. Because of this, adjacency lists are more commonly used in real-life applications. Let's see what are the advantages and disadvantages. Let's summarize advantages first. It saves memory, makes traversal easier, and are used in BFS and DFS. But they also have some disadvantages. Second, if an edge exists is slower. The structure is slightly more complex. Every representation has its own pros and cons. The key is knowing when to use which one. Adjacency lists are widely used in social networks, map and navigation systems, networking routing, and web crawling. So to summarize today's lesson, adjacency lists store only the necessary connections between nodes, making them efficient and powerful. And that's all for today's video. I hope you are having a clear understanding about graph representation using adjacency list. If you enjoy this video, don't forget to like, comment, share and subscribe for more lessons on data structures and algorithms. See you in the next one. Bye for now.